Hello, welcome back. This is day 23 of Advent of Code 2024. In today's challenge, we have a list of connections that represent connections between two computers, and the whole list represents a network of computers that are connected together. For the part 1, we need to find sets of 3 computers that are connected to each other, so each computer is connected to each computer, and this is the set of 3 computers. And in the example we have 12 such pairs, and later on we need to filter these sets and find the sets where you have at least one computer connected that starts with the letter T. And yeah, that's for the part 1. For the part 2, we need to find the largest set of computers that are connected to each other. So we need to find a clique in the graph of our network that represents a full mesh. So this will be a complete clique. So in the example, this is a clique of 4 computers, and we need to get the names of the computers and sort them alphabetically, separated by a comma sign. So starting with the implementation, I first have a method to parse the data. I have a default dictionary that will hold set for every entry, and I go over the data line, so basically over the connections, split the line at the minus sign to get computer name on the left and on the right, and I insert it to the dictionary. So for each computer I store the connections. So for the computer KH I store the value TC as a connected computer and the KH as the key, and the same in the other way. So TC as a key and KH as the element in the set that represents computer connected to it. At the end, if I iterated over all lines, I return the connections, so the dictionary. For the part 1 and 2, I use Bron-Kerbosch algorithm to find maximal cliques. So this algorithm finds the maximal full mesh constellations of the nodes in the graph. So for the part 1, I run this algorithm that stores the outputs in C1 variable list, and then I do some processing after it. So we are interested only in maximal cliques that are of size 3, and if this is the case, we store it as a sorted tuple to avoid multiple outputs that may come if we use another if statement. So if we have a clique that is larger than 3, we do all combinations of size 3 and then also do a sorted tuple and add it to the set, so we get the duplicates away. So that's why I use sorted and tuple to have a hashable object, and then sorted to keep it equal for the both cases. So if we have one entry here and the combinations returns the same entry here, so it will be applied only once. And then for the part 2, we are interested in the sets that start with T letter. So I iterate over the outputs in the first for loop, and I check if any of the entries in this clique, so any of the nodes, starts with letter T, and this function returns true if it's the case. So I filter it out and then take the length of the returned list, and this is the answer for part 1. The part 2 is pretty simple because I use this algorithm that already finds all maximal cliques. So basically I just go over the C1 with the max function and use length as a key, and return the maximal clique of maximal length. Then I sort the node names and join it with a comma sign, and this is the answer for part 2. So part 2 is pretty much free win if you used this algorithm for the part 1. If I run it, it's pretty fast for the small example input, so it's 7 in the code we saw before, and for the real input it's also pretty fast. If I move to right directory, it is not bad, it runs pretty fast. Okay, but you might ask, what is a maximal clique? Yeah, the maximal clique is a set of nodes in a graph that have connections to all the other nodes. So if we have 4 nodes in our graph and the node 1 is connected to node 2 and 3, the node 2 is connected to node 1 and 3, and the node 3 is connected to node 3 and 1, and the node 4 is only connected to 2, then the maximal clique of this graph would be a set of the nodes 1, 2, and 3. If we would like to take the 4th node to our clique, we would need to make new connections from the node 4 to other 2 nodes. So we have full mesh, if you are familiar with full mesh in the networks. Okay, that's it for today. I hope you enjoyed the video, and if so, please leave me a like and please subscribe to the channel so you don't miss new videos. I would also like you to comment which method did you use to get the right answers. If you also used some known algorithm or you developed your own solution. So for now, that's it, and until next time.